At the end of the last video, we had just found 0. And again, I want to make sure everybody understands this is not no solution. Just because a number 0 is in there, 0 is just like 5 or 10. That doesn't mean no solution. You do 0 divided by 3, which is just 0. So you go over here and fill in your 0. So my ordered pair, or my point of intersection, is 0, 5. So since we plugged into this equation, we need to check in this one. So I've written the equation over here, 3x plus 2y equals 10. We're plugging 0 in for x, 5 in for y, and see if we get 10. And you can probably see in your head that it is going to be 10. So 0 plus 10 is 10, and I have 10 on the right. Boom. So I can walk away and know I got that problem correct. So easy to check. So I'm begging you, if you have time on the last 4 on your test and final, go back and check them. So easy to tell if you've made a mistake. If you got 9 equals 10, that means somewhere over here you made a mistake. So look at your work and find it. These will always balance if your point of intersection is correct. Okay, let's move on to the last page. I don't know if we'll be able to get done in one video, but we'll try. So notice all of them say use the elimination or addition method. So like I said on the test, when you submit your work, I need to see, and on the final, I make everyone submit their work, by the way. I need to see that you're using the method that they ask for. Okay, so elimination method, when you see that, what should pop in your head is make opposites and add. So on the substitution method, remember we had to solve for y or solve for x. That was step 1, but on the elimination method, we make opposites and add. So if this is 2x, I could make this negative 2x. This is 2y, I can make that negative 2y. So you're probably thinking, well, how do I know which one to pick? Well, it doesn't matter, but if I have ones that are already opposite signs, that makes it easy for me. So if this is 2, I need this to be negative 2. So what do I need to multiply by? 2, right? Because it's negative 1. Isn't negative 1 times 2 going to give me negative 2? Does everybody agree? Negative 2x, positive 2x. All you have to do is do that first step and see that they are. So the first one will not change. And the second one becomes negative 2x plus 4y equals 4. So I did my arrows so I wouldn't forget all the terms. So before I do the next step, I say, did I make opposites? Yes. Here's my opposites. So now this is where it gets its second name. So elimination is from here. Where it gets its second name is now we're going to add the 2 equations together. So 2 minus 2 was 0. Gone. Don't write x. Don't write 0x. They're eliminated. And remember how there's always an imaginary 1 there? So this would be 5y equals 4 plus 6, 10. So we can see y is 2. So we come up here and we put 2 in the y slot. So now we need to find x. And remember how I said pick one that doesn't have very many negatives? Negatives are usually danger zone for students. So I would say the top one is perfect way to find y. So we have 2x plus 2 equals 6. Get your x alone. 2x equals 4. Divide by 2, divide by 2. So x is 2. Nice. Look at that. So I'm just going to check one more just to save time so that we're not boring you with all these videos. So we went into this one with our y value. So let's check this one. So our check is going to be into this equation. And we're plugging x in as 2 and y in as 2. So 2, 2. And we want to see if we get 2. So does negative 2 plus 2 times 2 give us 2? 4 minus 2. Ding, ding, ding. Same number on both sides. That means we can go up here and box our answer and walk away with confidence that we got that correct. They get easier and easier, right? Okay, number 12. So this one has a definitely easier method and harder method. So I look at the x's and go, well, I could make it 12 and negative 12. But look at the y's. This is 2. Couldn't I easily make this negative 2 by multiplying by 2? So in this one, eliminate the y's. Much easier. Would you get the same answer if you decided to eliminate the x? Yes, you would. So one person at your table could eliminate the x's, another person could eliminate the y's, and you both end up with the same answer. So like I said, the y is a little bit easier because this is positive 2y, so we need this to be negative 2y. Well, it's negative 1 right now, so that means I need to multiply by 2. 2 times negative 1 will be negative 2. So our top equation stays the same, 4x plus 2y equals negative 2. And this next equation is going to get distributed, and remember there's a 1 there. So 6x minus 2y equals 12. So before you go on, check to make sure you've made opposites. No, yes. So the minute you see the opposites, cancel them because 2 minus 2 is 0. And now we're going to add the equations together, hence the other name, addition method. So 10x equals 12 minus 2 is 10. So x is 1. So we go up here, put our 1 in the x slot. So they both have 1 negative. Let's go ahead and use the top one. So make x 1. So 4 times 1 plus 2y equals negative 2. And remember, it doesn't matter which equation. I forgot to put my 1. Well, I did put my 1, but it ran into my arrow. So it doesn't matter which equation we use, we'll all get the same answer. So don't think there's a right one and a wrong one. So I'm putting it in for this x. X is 1. I could have put it in for that. So we get 4 plus 2y equals negative 2. Subtract 4 because we're trying to solve for y. We get 2y equals negative 2 and negative 4, negative 6. Divide by 2, divide by 2, y equals negative 3. And I think we might have time to check it, so let's check one more. I do like checking them because it's so exciting when they check. Okay, so we went into the first equation, so that means to do the check, we're going to have to go into the second equation. So put 1 here, put negative 3 here, and see if when you plug those in you get 6. So it's 3 times 1, be careful here, minus negative 3. Is that equal to 6? So there's a minus there and a negative there. 3 plus 3 is 6. Yay! So once again, I can go up here and with absolute confidence know that I got that problem correct. This will be your favorite eventually as you move up in math. This is what students do the most of. because lots of times equations are already given in standard form, and when they're given in standard form, it's just easier. Okay, so 1, -3 was our solution, so let's tackle this last one. So we have x's we could cancel if we wanted. This one's 6, so we could make this -6 easily by multiplying by -3. Or we could cancel our y's. This one's 1, this one's 3. We could make that one -3 by multiplying the top by -3. Doesn't matter. Either one's good. So let's look at the x's. I like it when they're in front. So if this is +6, I say in my head, what do I need to multiply that top equation by to make it -6? And the answer is -3. So +6x, -6x. Because remember, my goal with the elimination method is to make opposites. So -6x minus 3y equals -9. Positive 6x plus 3y equals 9. So did I make my opposites? Yay! So now I'm ready to add. Oh, whoa, look at this. 3y minus 3y is 0. And 9 minus 9 is 0. Now that's an interesting problem. So I say to myself, okay, there's no variables left, so I can't solve. So anytime the variables both eliminate, which they did, 6 minus 6, 0, 3 minus 3, 0, then I tell myself, oh, in Module 5, we learned that when all the variables are gone, it either has to be no solution or infinite solutions. So how do we decide? We look at this line and say, is this a true statement or is this a false statement? A couple pages back, let's see if we can find it. We had this case. That was false. So we wrote no solution because 6 doesn't equal -5. But this is just the opposite. This is a true statement. So when it's true, it'll be just the opposite of no solution. It will be infinite solutions. So true means infinite solutions. What does that mean? I don't know if you remember this, but infinite solutions means one of these lines graphs right on top of the other one. And you know how you can tell? Times 3, times 3, times 3. So one line is just a multiple of the other line. So they're the exact same line. And remember how we have to say on the line? Remember why? I can find that in our notes too to show you. The reason we have to say that is because if we say infinite solutions without any line, that means this is a solution and this is a solution and this is a solution. No, the infinite solutions are only on this line. So we have to say infinite solutions on the line and then name the line. So this would be infinite solutions on the line. Since this one is the simplified form of that one, let's use this one. And it doesn't matter which, but there isn't a GCF. So if you remember your vocabulary, this means they're coinciding lines. And this is a dependent solution. So this is your answer. But I'm just going over some vocabulary. So coinciding lines, and it's dependent because one line depends on the other line. That's it. See ya.